Hello everyone, Mancini here, and today we're talking about VPNs. Now, VPN is something that has been making the news recently, especially with Netflix saying that, talking about VPN and how some users are using VPN technology to circumvent their geolocating. Now, some people use this technology, don't really know what it is, and want to know what it is. So, for instance, we'll get started on VPN. So now, a VPN, just think of this. So you get for instance, you get the internet. So just a big cloud. Okay. Now, the internet in nature is public. So any traffic from, say, host A to host B, technically, is barring any type of encryption, but any unencrypted traffic can be sent through the public network and intercepted. So that makes it not very private, right? Another thing too is that with VPN, if I have, let's say, a LAN in Germany and a LAN in Canada, I can't extend my LAN through the internet, okay? Because that's obviously, as you know, you'll have public address space and private address space, so we can't route that. But with VPN, what we can do is create a secure channel that's more of a LAN type of extension from point A to point B, and then inside this is a fully encrypted tunnel that tunnels all the traffic from one point to the next. This is more typically what companies use it for. For home users, when you want, let's say, to go to Netflix or to maybe a site that might be blocked in your country, what you're actually doing is, let me just erase this. So that first example of how VPN is used is to connect two companies' locations together. That's called a site-to-site VPN. There are, by the way, many types of VPNs. I'll go over a couple and what the differences are and what they're used for. So just to recap, actually, so a site-to-site VPN, you have site A, and then site B. Okay? Now, site A, site B could be in different countries, different cities. It doesn't matter. As long as there's an internet connection, or it doesn't even have to be necessarily an internet connection, but typically it is, because you have VPN to go through the internet, okay? Or if a company invests the money, you don't actually need a VPN for two sites. What they have is a layer 2 circuit called something like an EPL, okay? Or it's an Ethernet private line, or T1, or something like that. But the VPN is a cheaper way of being able to secure and using a cheaper form of communication, such as the internet. Okay. So now, the example for a home user trying to get to, say, Hulu or something that is not authorized because they're in a different country, what happens is that a VPN provider will have a server, a VPN server, okay, with an internet connection in that respective country that is allowed to access that content, okay? And all you're doing, really, is using your computers to VPN back to this VPN server, and then what will happen is that, say you have your IP address from your ISP is 1.1.1.1, you will assume a public IP address of the VPN server. And this is why you're able to access Hulu and stuff like that, because the traffic, even if you went to even if you went to a website that's hosted next door to you, okay, so 2.2.2.2, and it's your friend that lives right next to you, because of the way the VPN is, all the traffic on a point-to-point VPN, now there are things called split tunneling and stuff like that, but let's not get too much into it. For the sake of this the conversation, on a point-to-point VPN with no split tunneling and stuff like that, you will have to send all the traffic directly to the server, and then from the server comes back down to 2.2.2.2. The reason why you wouldn't do split tunneling, by the way, split tunneling is a technique where I can have my VPN traffic. So say I'm a company and I have users with the internet, and I only transport my LAN network inside that one tunnel. So say 192.168.1.0, and I want the VPN to talk to 1.0, but all the other internet traffic, don't send it to that other network. You can send it through the internet, the local internet. So only the destined traffic for the VPN network goes into the VPN. So that saves bandwidth and a whole bunch of other admin back-end work. So that is exactly that's exactly how you'll connect with your home network, for instance, if you want to access other sites, or just simply protect your network. Because the next step that we're talking about is inside the VPN. Okay, it's not just this technology that allows you to access Hulu. Another thing it was developed for is security. So inside the tunnel, there are many different types of authentication. I'll speak about one, which is called, so inside this tunnel, okay, it's a fully encrypted tunnel, okay, and there are, like I said, a bunch of different ways of encrypting it. One is called IPsec, IP security, okay. So in IPv4, or the IP that you're pretty much using today, when it was built, it was never built with security in mind. Because if you go back to the internet, to the beginnings of the internet, it was meant for kind of VPN type thing, just a point-to-point link. No one really worried about security during that time. So then what happened is that some engineers came up with a way of creating something called IP security. So what happens is that inside the packet, there is the data frame, or sorry, the data portion of the packet. So what happens is that we encapsulate the data portion so that it cannot be intercepted. If you use a packet sniffer to check an IPsec communication, you'll notice that you won't get much of anything. Okay? The only thing you'll get is the source address, the destination address, all of the header info, and that's about it. Now, there's other types of encryption too. So there's IPsec. Okay. There is SSL VPN. Okay. Now with an SSL VPN, I can import an SSL certificate that I bought from, say, GoDaddy or Netfirms or something like that, and import my own encryption. I own the keys. I own everything. So the thing is with IPsec, because it's a standard encryption, it's heavily under attack. Well, not under attack, but it's well studied. Whereas the as SSL, you can change things up a bit. You can put a 48-bit encryption. You can store the keys yourself. So yeah, that's one. Then there's other ones that are less secure. IPsec and SSL, in my opinion, are the two most secure ones. Okay. Then there is one more to talk about. Okay, is PPTP. So that's point-to-point tunneling protocol. It was developed with alongside with Microsoft, and they have their encryption and their authentication techniques in there. So PPTP uses MS-CHAP or MS-CHAP v2. Okay. The problem with MS-CHAP and MS-CHAP v2 is that the hashing techniques that they use for the encryption have been broken. So you can actually, if you extract the hash, you can dump that in to a hash tool and grab the info. Again, this is one of those things where a lot of encryptions have been broken in the lab, and then we rush to go ahead and upgrade, as we should, especially as businesses and stuff like that. But for home users, even PPTP is pretty secure. In order for someone to intercept this, they have to take control of one of your machines and kind of break in. Because see, what happens is that as soon as someone tries to break into a VPN, the tunnel collapses, and then the session's over. So it makes it harder to break into these things. But I would definitely recommend, as a company, should always be IPsec or SSL VPN. Okay, there is one more VPN that I want to talk about. Okay, and this is a Cisco proprietary VPN. Okay, only Cisco devices use this type of VPN, and that's called DMVPN. Okay. Now, with DMVPN, we get rid of the whole site-to-site hub and spoke topology. So what happens is that in a DMVPN environment, I have my hubs, my spokes. Okay. Now, if I'll just label these 1, 2, 3, 4. Now, if host 1 wants to speak with host 2, instead of using the hub to talk to the hub, then to talk to 2, okay? See, one thing with the VPN is, as you can imagine, if the hub blows up, the whole VPN tunnel goes, everything goes down, because there's no VPN concentrating, okay? And for the most part, that's fine, because you can have redundant VPN concentrators and stuff like that. But there are some disadvantages, even if with the redundant part of it. You have to have massive links to support your entire organization and stuff like that. Well, with DMVPN, if host 1 wants to speak with host 2, it establishes a session from host 1 to host 2. It's not actually talking to the hub. Another thing is that with DMVPN, we can use routing protocols inside the VPN tunnel. So I can establish a VPN tunnel and use something like OSPF or EIGRP to converge routes, so that if this gets cut, the routes can reconverge. Something with IPsec, inherently, not that it can't be done, if a tunnel drops, it takes either a while or the session will stay up, because it's not there's no routing protocol or anything inside there, and it's not stateful enough to say, oh, something dropped, reconverge, or disconnect and reconnect. So similarly, if host 1 wants to talk to host 4, it doesn't need a hub, it goes to host 4. Now, so I hope that this helped explain VPN to you and exactly what it is and why it was built. If you have any questions, of course, leave them on my video comment section, and if you want, you can subscribe and also visit my website, SeanMancini.com. Have a good day. Bye.